Hello everyone, can you hear me okay? Okay, let me see if I can use this. All right, using big data to solve QoE problems, it seems a little bit excessive, but I hope to explain all of that and cover a case study. It's an actual big data project that we're involved with, and hopefully you can take away a few lessons learned from what we've done. Okay, what do providers want? Well, if we look at it, you have some of the biggest names in the industry who have access to some of the best content in the industry, yet they're losing subscribers at an alarming rate. If you further look at it, the same two companies, they launch an OTT service and it looks like they're gaining essentially what they're losing. But unfortunately, what we're seeing today is even with OTT, the trend is about 18 to 19% churn there as well. So there's really no known holy grail yet to where this might end up. So what do people want? So this is kind of an interesting thing. So Real SEO, they did a bit of a study for YouTube to find out how many cat videos were on YouTube. This is back in 2015. And they found out there's about 2 million cat videos. So, and if each cat video was about a minute, that's 417 million hours of viewing time, okay? So why do people watch a cat video? Well, you didn't do anything to get it. Somebody probably sent a link to you or something. It wasn't a huge, it didn't cost anything, and there was no time commitment because it was less than a minute. And the recommendation came from a friend of yours. Hey, you gotta see this, okay? So that's where you get a cat video. So I took that further and we talked to 3 millennials in our office and asked them what influences what they watch. And they were all over the place. They're all 30-somethings. One's in the middle of buying a house, the other one's having a baby, and the other one, nothing new is going on. But it's a moving target. So prime time isn't what it used to be, not even live. I mean, Nielsen keeps coming up with new ways to describe what live is, and people don't have that, and it's all over the place. So to try to connect those two dots has been very difficult. So it used to be kind of a mile wide, inch deep. So basically, if your equipment was functioning right, then your service was functioning right. And you had basically a basic understanding of your program content through ratings, and you had a generalized understanding of your audience by gender, DMA, whatever it happens to be. But that's not sufficient anymore. So now we need QoE to fill in some of the gaps with the QoS. You also need to decouple advertising from programming because it's not necessarily a one-to-one relationship, or you won't reap the benefits of it completely. And you need to get an individualized understanding, not a generalized. And if you do that, you become more of an inch wide, mile deep, and you see individuals evolve instead of this generalized grouping of people, okay? So to do this, though, requires an enormous amount of data, and because everything's a moving target, it has to be processed very quickly. Okay, well, big data to the rescue, right? So that's the one technology set that we know of that can process enormous amounts of data in real time. And that's exactly what this project was. But what do we know about big data? So you got the 3 V's, volume, variety, and velocity. So those are the 3 things that, how do you know this is big data? Those are the 3 things that you kind of weigh and measure and determine if you fit into that category. But what have we really learned from it? It's new and evolving. It takes new skills. There's very few standards. It's complex. Security and privacy could be an issue. And one of the bigger things that came up is the accuracy or the confidence of the data. So it became such a problem that it even was deemed the 4th V, called veracity, the uncertainty of data. And studies have shown that 1 in 3 business leaders don't trust the data that they have. So now you have a moving target. You're trying to build a predictable business on consumers that are all over the place. Competitors are global now. So how do you pull all this together and do it with data you can't trust? Okay, this is not getting any scarier, is it? So anyway, so getting into it, here's the case study that we did for a quad player in Europe. So don't worry about trying to read all this. I'll just paraphrase. So the main high-level goals were obvious. Subscriber insights, an investment strategy for their infrastructure, where do they get the biggest bang for the buck, and also business intelligence. How do you kind of stabilize your revenue and how do you grow it? Those are all the common things that you want, and there's a little more detail in there. But our particular client, they wanted to start with understanding silent sufferers. Does everyone know what a silent sufferer is? All right, so for every one person, so have you ever been to a restaurant and had a bad meal? And how many people complain about it versus how many people just don't complain about it but then don't come back? That's what the description of a silent sufferer is. So they know how many callers that they have call in and complain about the service, but they don't know how many people also have suffered but then just decided to leave. Okay, so that's the problem that they wanted to do. It was a big unknown to them, and that's where they wanted to go. And it also allowed them to meet their customers where they are, at a common ground. We understand you're having a problem, let's deal with that. Okay, and then they get into the other ones. And then with that, they want to see what the relationship was with churn. Okay? So data sources, they had, essentially we integrated 7 legacy systems. Everything from CRMs, BSS, OSS, MAM, NMS, PM, FM. If it had an acronym, TLA, we integrated it, okay? And then there was some, occasional services as well, but then they had that data gap that I described earlier. And that's where we came in with what they deemed as Service Quality Management System, or SQM. And this allowed us to help supplement the data and the gaps that they were having. But the key to that was to get this last mile and end user data as cost effectively as possible, because you can't throw a bunch of money at it, because then it's costing you more than the problem it's trying to solve, okay? So to be able to get that cost effectively was key to even move forward with the project, and we were able to do that in a manner that met their needs. So another view of it is the topology, and here I just kind of want to point your attention to the quantities as you go out from the central head end, regional head end, the various ISPs and consumer equipment. So 3 central head ends, 170 regional head ends where they do program insertions, access switches counting into the millions, and then they have on paper 15 million IPTV subscribers and also OTT subscribers as well. Does everybody see this okay? All right. Am I going too fast? Is it about right? Okay. And if you look at the red stars there, those are the SQM, the Service Quality Management components. So at the output of the central head ends, the regional head ends, and then the key was this last mile, and the reason why that was so important is because it's the last point of control. Because if you jump straight over to the end user or the consumer, then you got all that variability in there too. Okay, why did they stop the service? Where were they? It raised more questions than not when it pertains to the quality of the service being delivered. So they couldn't get that information, so they needed to supplement it. So last mile probes allowed them to have a cost-effective way to get telemetry information about the service without imposing, an end user into the equation. And this is how we kind of solve the veracity problem with the data trust in their mind. Okay, if we look at the architecture, first let's start with the legend on the right. Microservices, and then if you see the light blue there, that's Spring Boot applications wrapped in Docker containers, orchestrated by Kubernetes. So the whole system is architected that way. And then if you look on the left side there, we have the 7 legacy systems coming in, your CRM, BSS, all the acronym soup there. And that's where we have our variety, right? It's a bunch of different interfaces, everything from straight database to REST to SOAP, you name it. Comes in through an adapter and via camel libraries to normalize the data through a message broker and into the data augmentation module. And then on the other side, this is where we have our fast moving data. So this is from the customer premise equipment and the SQM probes that were deployed all over their network. And the data coming in is, in the terabytes. So that's coming in very quick, and it's very much event driven. So a subscriber comes online, throws an event, the system reacts, okay? And that's where we get the velocity of data. It too comes in through an adapter, Camel libraries, Kafka topic, and into the data augmentation module. And then the 9 different systems comes together in the data augmentation module and is stored into the database as Kafka streams. And it can be pulled out by the KPI, KQI policy engine in a map-reduced manner. All right, I know that's a lot of information, but that's kind of some of the nuts and bolts of big data. It's basically data in, data out, and a lot of it, and you do it in real time. Okay, all this can happen in a second for 15 million viewers. Okay, so I'm gonna cover a little bit more on the data augmentation module and the KPI, KQI, and policy engine, because those are kind of the key things. When you get on the outside of that is, you know, how do you present reports and the alarm generation and those kind of things. Is everyone still with me? All right. So this is that data augmentation flow, and you don't have to read that on the bottom. It's essentially the 9 systems that we had talked about. And it's very much event driven, which is why we got the customer premise equipment on the left. So the first thing that happens is some event. A subscriber comes online, or there's an error, or they're changing channels. Something is changed in the status quo. They're not just watching TV, or they're not just not watching TV. So something changed. And what that does is it kicks off the pulling of data from all those different kinds of systems. So the first thing it does is it goes to the CRM. Okay, who's the subscribers, the active subscribers are online, what content are they watching, and what path did it take? So now you know the topology and where the content got from its origination to the end user. And then we augment that with that fast moving data with the, you know, were there any equipment problems reported at the same time? Or what are the active equipment problems? And also, were there any stream problems or current or active at the time? And then we analyze that information and pop out, you know, the response or the report. It could be that everything's fine, but then we'll actually update the record for all the active subscribers saying they got online, everything was going fine. Okay, everybody still with me? All right, so now we'll get into a little bit deeper into the analysis part. So what they wanted to do is break the system into 3 different domains. You got a head end, the network, and the subscriber. Make it as simple as possible. And the key things that they're trying to do here is from the head end, you know, how well are the services prepared for delivery? And for the network is how prepared is the network for delivering it, or how well is it delivering it? And then how well is it being consumed from the subscriber's domain? And to do that, we have all these, has this got a pointer on it?
Little red.
Oh, got it, right here. So we have these KPIs and KQIs. That's a key performance indicator or key quality indicator. And I'll talk about those in a little bit. But we create a whole series of those ratios and topics, the indicators for each particular one based on what we need to do. Okay? So getting into the KPI and KQI, the top 3 KPIs, and again, there's a lot of these depending on who's using what. And you know, the top ones are service availability, again, because we're looking at silent sufferers. That's all we're looking at in this presentation here, is that one element of all the goals that they had. So service availability, the percentage of subscribers, active subscribers with degradation, and the recovery time, very obvious. The other ones are what I had described on the previous slide, is the availability factors of the service, the network, or the consumption of it. And because our client was very concerned about biasing or manipulating data, we used as many industry standards as we could to help govern these subjective measurements, okay? They also had their own review board of people who would review with our data scientists, you know, the KPIs and the KQIs to make sure that they were done in an unbiased manner, that the data that we used to pull for all that analysis was acceptable as well. So the big thing was data trust, because they had tried other things and it told them nothing, okay? So a little bit deeper dive, and this is one of the KQIs for the head end. And again, here it focuses on the service. And as you can see over here, this is the number of KPIs that are used to calculate one of the KQIs. So again, it gets complex pretty quick. But they broke it down into the media, the EPG, PVR, basically all the services that might be consumed. And they also look at number of active subscribers. One of the interesting things on the Headend though was the channel rating. And this isn't, you know, a competitive thing. This is their own subscribers and their own active services. So at any given period of time, and these are all based on measurement times, and you can adjust that however you want. So say over the last 1 minute, we have this many active subscribers and this many of them are watching the first channel or the second channel or whatever, okay? And that way they have a channel waiting. One of the other things that they wanted to do was to make it easy for their organization. Every KPI and KQI was designed around 95. Greater than 95, you're good. Below 95, required action. Simple for everyone to get their head around that, okay? So that's kind of what this one looked like. And then we get into the network. This one's kind of interesting because what it does is it looks at the system health, you know, both the equipment as well as the streams going through it, and again, a number of KPIs and KQIs to calculate it, but it'll actually traverse that path. So if you're online, you request a piece of content, OTT, IPT, however you want to get it, it'll actually traverse that path all the way to you and create a KQI for you. So that way it knows the health of the path all the way to you. Okay? Now you get into the subscriber side. This is very much quality of experience because they'll look at the coded video frames, the audio frames, and the overall experience. But one of the interesting things here is that, you know, they weight pretty heavily. Okay, the media itself is only 40% of the equation. So you think if your audio and video is getting there, you're done, right? They gave that a 40% total. All the other services equaled it. The PVR and the VOD, that equaled what the actual live service was. And then the time it took to get to something you want to watch was pretty high as well. So has anyone heard of the Netflix 20? It takes 20 minutes to find something on Netflix, right? That's a problem, and we measure that for them because they have over 1,000 channels, right, by the time it gets to the end user. So if you watch one channel every day, it'd take you like 2.5, 3 years to watch everything. No one can do that. So finding something to watch is hard enough. To keep them engaged, that they come back again, that's another part of the equation. So they're trying to figure out all these different kinds of things. So they measure all those things, all right? Very important to them. So now you're getting tremendous amount of data coming in very fast. So you can get what they call an alarm storm, right? So if you had a major switch or a component have an impact, we do what we call impact analysis. So we can immediately tell how many people were affected, what type of programming, was it during advertising or whatever. And in this particular case, it gives you an idea. So if there was 10 alarms in 1 second, then we'd trigger another alarm. And then if there were 15 of those alarms in 30 seconds, we create another alarm. And then we can do that however we want. And then it's very elastic. You can adjust the times and the amounts however you want to get whatever picture you need to get. And the data's all there. You can always drill down, and you can even hand off different pieces to different people, okay? Because this is quite literally a tremendous amount of data coming through the system. So that's how we aggregate up even faults. Now when we get to OTT, it was a bit challenging. The Headend and the subscriber side, that's pretty much the same as what it was before. However, we had to make some modifications because we have no insight into the subscriber part, or inside the unknown part. And the big one is you know, when the media leaves here to where it shows up on the edge device, because that's the first place we see it. So this is the last place we see it. This is the first place we see it again. A miracle occurs, and it's a competitor for our client. So the chances of them sharing their performance data of their network, it's still a work in progress. We probably won't get that. But anyway, so what we do is we actually have more of those last mile probes, and we can cross-correlate and aggregate the data such that we can tell which CDN, which ISP, and you know, we can basically deduce what the problem is. The other thing that they do is they can actually throttle some of the services that they have here and see the propagation through the system as well. because the big thing that we needed here was the chunk download time. If we had just that one piece of information, life would be good. So we're trying to figure out a way to get that as realistically as we can without having to do a whole bunch of statistical analysis, okay? So, as you might know, the key things for a good OTT experience is the buffering. All the other things are true. You know, the blocky video, the, you know, black, freeze, pause, all that stuff is very important, but the blocky thing is what makes OTT stand out. And the rate of buffering is a big piece of it, and I have a calculation down here I'll walk you through. And then the other one is the average bit rate. And we've already been able to prove that the higher the average bit rate and the minimal amount of buffering, the longer somebody will stay on the service, whether it's the content they like or not. If it's high quality and rock solid, they'll sit there and watch it because it just looks good. And we've actually measured that. The other one is the frequent switching. So the OTT, you know, there's a 4K question in the previous presentation about, you know, how is 4K being delivered? Well, we measure 4K over OTT, and you'd be surprised. So I'll give you a couple of stats, but don't hold me to it. I'll have to follow them up. But for a mobile provider, only 70% of them can get 720p out to an end user consistently. There's one number. And we've actually measured 4K even over good networks and all those other things, where the amount of time that you're getting 4K to the end user is not there. And in my personal opinion, ATSC3 is probably the only way to get there consistently. A consistent, good experience. And the other thing that I like about ATSC3, this isn't about ATSC3, is the second screen. I would totally tie that into it so you can get all this end user usage data and close the loop all the way back. That would be absolute magic, and then over-the-air broadcasters can compete with all these yahoos. All right, enough on my soapbox there. So getting into the buffering, so what we have is we have 5-second chunks, and then we have a window that we adjusted for 12 chunks in this example. So that's 60 seconds. And then the end device has a 10-second buffer, so that they add up to 70, okay? So 70 seconds is where this, in this example, where that is. And then we measure those chunk download times, and if the 12 of them add up more than 70, then there was buffering. And again, this is very elastic. You can do this in as many different ways as you want to get the kind of data presence that you want. But it's so key to have these kind of parameters in order to get to the root cause. All right, everybody still with me? All right, so some of the solution outputs. So again, our main target was understanding or uncovering silent sufferers. And again, with silent sufferers, it's like who had a problem and what response did they take? So what we've been able to do here with the SQM system is as soon as that there was an error showed up on the system, we would traverse all the way through the end user, we'd know who it was, and we'd simultaneously open up a ticket, a trouble ticket, as well as update the CRM for each individual user, noting that you had a problem. And then, when the problem was resolved, so the help desk and everybody else, they get this information immediately, right? And they're like, oh my God, I gotta do something. And then, whenever the problem's resolved, the SQM system will verify that, close the ticket, and update the record in the CRM for every active user who was impacted by that. So essentially, there are no silent sufferers. We know everyone who's suffered due to a quality degradation. And we can do that in about a second for every subscriber. And we can actually proactively send a message, depending on what kind of technology they have. We can send a message to their set-top box, pop it up, Big Brother-ish, I know. Or we can even auto-dial them if they have older technology and explain, it's like, hey, we understand that you had experienced service degradation. We're very sorry for any inconvenience this might have caused you. Maybe we can take $5 off your next monthly bill, or whatever it happens to be. So that's what they're trying to do to understand these silent sufferers and try to figure out the number it is. Does anybody have a guess on what the percent silent sufferers?
25.
No guesses, come on.
25.
90. 95.
Like 96, 94 to 96. It's really high. It's, well, again, most of you guys are over-the-air guys, so you're used to good quality. These guys aren't. They're like good enough, right? So that's the other thing that you got to look at, right? Right, so it looks all gloom and doom. Yeah, you have all kinds of access. You got variety. It's whiz-bangy. It's cool. It's all good things, and people will use it, and they have. But give them a reason to come back. Give them a reason to come back. And with ATSC3, I'm a big fan of it. There's technology there that you can wrap all this into it. Okay. Another thing, before we installed the SQM system, if someone called in, they'd reboot the set-top box. That's about all you can prescribe them to do. Has anybody helped a non-technical person troubleshoot a problem over the phone? It's kind of difficult. It can be a challenge depending on the issue and the person that you're working with, right? So now we have such insight into it, we can actually go in, know if it's the cable modem, we know if it's the Wi-Fi router, we know if it's the set-top box, or we know if it's their end user device. We can actually know there's a problem, remotely fix it before they even finish experiencing it. So that's how fast the system can actually react to that. So they're very happy about this, saves them a number of truck rolls, and the customer satisfaction has gone up quite a bit. So some of the other main outputs for this particular client is we talked about the help desk, and it's completely automated where every consumer is notified, and we know what they are, and we can meet them where they're at. And then the marketing people are taking this information to try to understand what they can do with the information to keep people from like dropping the service, because that's the big thing that they don't want. They want to kind of stabilize that because of all the cord cutting. And then sales. So now you have a record of people who have had no problems over the last 6 months or a year. Okay, a good time to kind of convince them that this next package or next tier service is what you want. And then on the business development side, well, the network operations, we kind of discussed that in the previous slides. They like having the additional information. They can pinpoint problems very quickly and remote repair things rather than roll trucks or take some amount of time. Then the business development people, they work with all these kind of things to refine those, as well as their big thing was service level agreements with any other third-party services or partners that they have as well. And of course, the executive team, they're interested in the business intelligence to understand, revenue, expenses, what they can do to stabilize things and grow their ARPU. So, in summary, moving forward, so they have some churn prediction and prevention models that they would like to test with the data that we're collecting. Okay, we're still figuring out a few things, and they're fixing a lot of things in their network. There's been countless things that we've fixed on their network. It's all the IP stuff. That was a problem for them. And also AI-assisted infrastructure investment recommendations. So we're basically cataloging every time there's a problem, whether it's a soft problem, where the pitcher breaks up and it comes back on its own, nobody fixed anything, and it fixed itself, right? So all those things, we correlate all that information as well, and we'll run it through some AI in order for them to make recommendations like, hey, you have a choke point here, you need to upgrade this gear or whatever it happens to be. And then also the business intelligence. So some of the cautions, don't bias the results. It's so easy to make the data tell you what you want to hear. Okay, the garbage in, garbage out. If you got some data, anybody's played with a spreadsheet, a finance guy or whatever, you can make the data tell you whatever story you want it to tell you. So be very cautious of that. The other one is augment and fill data gaps. That's the veracity. And to that point, the data from third-party devices. So if you're working with an OTT provider or some other third party, have in your agreement up front, the ability to share certain performance data, things of the, maybe access to the stream, if it's encrypted, some decryption, those kinds of things in order to, if a big data strategy is part of your model to move forward to optimize your business, then that's key things that you want to look out at as well. Use available analytic services. There's a lot of them out there. And tying them together is where all the magic happens with the big data. So there's websites. Everybody can do Google Analytics on their website. There's a lot of third-party website analytics, there's social media analytics, depends on what player app, there's a lot of analytics there. There's a lot of ways to get pieces of the analytics, and now you know that there's something called delivery analytics if you're interested in that, and you can tie all those together. So big data doesn't have to be this big scary thing. You can start with one thing that you already have, and then tie it into one other thing, and then keep going until it's starting to tell you the story that you need to know. Gives you the information that you need. The other thing that they found out is, from the silent sufferer perspective, is take advantage of any customer interaction. Even a poor viewing experience is an opportunity to interact with a customer. Everyone, I'm sure everyone in this room likes good customer service. So back to that restaurant analogy, what if you're drinking your soda and it's flat, right? So you think you're the only one in the room that's drinking a flat soda? No, of course not. So, the waiter, waitress, whoever, they determine this, they're like, wow, this is bad. They change the tank and they go up and say, hey, Mr. Ziegler, we've discovered that we had, some bad soda. Can I refresh your drinks for you? Oh, okay, yeah, that's kind of nice. I didn't ask for it. They proactively acknowledged that I might have had a problem, and they did something about it. And then chances of you coming back to that restaurant, even though the food, all things being equal, yeah, they got a notch up. If they said, give me your check and, get the hell out, you might say, well, see you next time, ever. So you never know. So anyway, and if you have to choose, quality wins over quantity. So 4K, 8K, yeah, you could talk all that, but whatever you do it right. So if 720p is the best you can deliver, do a damn good job of that. If you can actually deliver 4K, then yeah, it gives you a competitive advantage, but only if you can do it right, okay? So just saying I have more bits than you doesn't guarantee you anything, because the better picture will win in a lot of cases. So that's all I had. Any questions?